So here I'm going to integrate 10x squared minus 53x plus 42. So that's quite a big quadratic. And I've got in the denominator 3x minus 2, x minus 4 squared. So I've got a cubic in my denominator. So to solve this integral, I'm going to need partial fractions. So let's do my setup for this integral. So that integral will be equivalent to, well, what have I got here? I'm going to need some partial fractions building up from the 3x minus 2. So I'm going to need an a over 3x minus 2. There's one constant. Then here I've got x minus 4 squared. So that's a repeated factor. So now I need to build up the powers. So I've got plus b over x minus 4. So that's basically to the power of 1. So I'll just leave it like that. And then plus c over x minus 4. And then that will be squared. And again dx. So now I need to find these constants by using partial fraction decomposition. So my setup for that, if I just bring this integrand out over here and do it out of the integral, I'll have 10x squared minus 53x plus 42 over 3x minus 2 x minus 4 squared. Then that will equal 3x minus 2 plus b over x minus 4 plus c over x minus 4 squared. So now what I'm going to do, I'm going to try and get rid of this denominator by multiplying both sides by this denominator. So if I put a bracket round it and times everything by this, so I've got 3x minus 2 x minus 4 squared. So this side I'll just have the numerator left, which is what I want. So 10x squared minus 53x plus 42. Then multiplying this by this, the 3x minus 2 will cancel out and leave me with that. So now I've got a x minus 4 squared. The b, I'll be left with that and only one of those. So plus b, 3x minus 2, x minus 4. And then with the c, that will cancel and I'll be left with just this linear term. Okay, so what do we do next? So I could actually multiply it all out. But first of all, what I want to do is, I can see here I've got a 3x minus 2. So if x was to be 2/3, then that would turn to 0. So that means I could use the cover-up method for that. But I'm not going to be able to use 4 for this one and this one, because it's a repeated factor. So I'm going to find my a and plug it into here. So using the cover-up method for a, let x equal 2 over 3. So 3 times 2 is 6 over 3 is 2, then minus 2 is 0. So let x equal that. So now what I'm going to do is, I'm just going to get this one to disappear and plug in 2/3 into all of this. So then I have 10 times 2/3 squared minus 53 times 2/3 plus 42. And then in my denominator, that will cover up. Then I can plug in x equals 2/3 into that. So then I've got 2/3 minus 4 squared. Okay, let's go carefully here. Let's do it in our heads. 2/3 squared is 4/9. So that's going to give me 40 over 9. So 40 over 9. So as that's over 9, let's try and get them all over 9. You'll see why in a moment. So 53 times 2/3 is 106 over 3. So over 9, that would be 318 over 9. So that would take care of that. And then 42, if I did 42 over 9, well, 9 42s are 378. So plus 378 over 9. So 2/3 minus 4, that's going to give me minus 3 1/3, which is equivalent to minus 10 over 3. So minus 10 over 3. So let's go through that. So if I square that, I'll have 100 over 9. So if I square it, it's 100 over 9. So then let's put that in my denominator. So 100 over 9. Now because I've got all over 9, I can just cancel the 9s out and just do the addition. So 40 minus 318 plus 378, or minus 318 plus 378 is 60, plus 40 is 100, over 100, after all that, my A is just 1. So A equals 1. So now as A equals 1, I can just substitute 1 into there. So then let's just bring this down to this level. So now I've got 10x squared minus 53x plus 42 equals x minus 4 squared. So let's multiply that out. So I'll have x squared minus 8x plus 16. Here I've got my b, so I'll need b times this one multiplied out, so that'll be 3x squared minus 12x minus 2x, that's minus 14x, and minus 2 times minus 4 is plus 8. And then multiply this one out, it's just plus, leave it as it is, c 3x minus 2. So now what I've got to do, I've got two unknown coefficients. So what I want to do here now is do corresponding coefficients, so I can match the coefficients to this. So let's get the x squared terms together. So I've got x squared, so I've got a 1 here, so 1x squared. I've got a b3x squared, so 3bx squared, that is. So 1 plus 3b, so that's my x squared. Now let's get the x's together. So x is, I've got minus 8, so I'll just write that as minus 8. I've got minus 14b, and here I've got 3c. So don't close off the bracket just yet. So plus 3c. So that's that one. And now all my constants together, I've got 16 plus 8b minus 2c. Okay, so with that, I know that 1 plus 3b must equal 10. Otherwise, that can't be 10x squared. So if 1 plus 3b equals 10, then b must equal 3. So I've got my b, that's going to be a 3. Okay, so if b is 3, let's plug 3 into there. So let's just do it here. So minus 8 minus 14 times 3 plus 3c. That should give me minus 53. Because that's my coefficient for my x. So minus 8 minus 14 times 3 is 42, so that's minus 50. Plus 3c equals minus 53. So then bring the 50 over, I'm left with minus 3. So 3c equals minus 3. In which case c equals minus 1. So that takes care of that. Okay, so after all that, I've now got my coefficients. Now I'm in a position where I can look to the integration. So let's take this off the board and make room for the integration bit. Okay, right, so that's my integral set up now with my corresponding coefficients already sorted out. So let's break it apart now into 3 different integrals. So here I've got 1 over 3x minus 2, leave it as it is, that's all good, so that's dx. Got a plus 3, so that's the same as 3 times 1 over x minus 4, so I'm going to bring the 3 out. So plus 3 out of 1 over x minus 4 dx. And here I've got minus, just a 1 there, so I can just leave that as it is and bring out the minus. So 1 over x minus 4 all squared dx. Okay, so I'm going to do u substitution for each one and go carefully at each one so I don't slip up. So let u equal 3x minus 2. So what I'm looking for here now is to get my log standard result. So the integral of 1 over u du equals the natural log of the absolute value of u plus a constant. Obviously I'm going to, with 3 integrals together, I can just do the plus c at the end. So u equals 3x minus 2, derivative both sides. So then du equals 3 dx, in which case dx equals du over 3. So now let's change this into u. So then I've got the integral of 1 over 3x minus 2 is just u. And my dx is du over 3. So I've got the 3 here which I can bring out. So I've got 1/3. I've got log of absolute value of u. And what is u in this case? 3 minus 2. So log of absolute value 3x minus 2. I'll deal with the plus c after I've done the other two parts. So let's take care of this one. So it's going to be plus 3 times. Right, integral of 1 over x minus 4. That's going to be the same as this one. So log of x minus 4. So we won't need to worry about any constants like this, because if we let u equal x minus 4, then du equals just dx, in which case I've got no 1s or 2s or 3s to put in front. So that takes care of that. Now this one's a bit different. So here I'm going to do a u substitution again. So if I let u equal x minus 4, du equals dx, so that's fine. But now let's do my substitution. I've got the integral of 1 over u squared du. Now that's not in the same form as that. So I can rewrite this as the integral of u to the minus 2 du. So this is just a power rule. So then this becomes u to the minus 1, raise the power by 1, divided by the new power, which is just the same as minus 1 over u. Okay, so now let's put that in. And what is u? It's x minus 4. So minus 1 over x minus 4. And don't forget I've got another minus here, so two minuses make a plus. So plus 1 over x minus 4. And now the important plus c that we always try to remember. And that completes the integral with all the partial fractions taken care of. Okay.